Alrighty. So worksheet number 1 and 2, we'll be going through that closer to the end of class. To start things off, though, I want to take a look at the question here. So there it is. People wandering through the desert occasionally see mirages that look like small lakes. Try and explain this. What I'd like you to do with this question is I'd like you to try and figure out what this answer might be. And you don't have to get the answer completely right, but what I would like to do is try and have you guys start a discussion with somebody that's sitting around you right now. So anybody that's right next to you, or if you're just the only person in the thing there, feel free to look behind you and discuss with folks around you. Do your best to see if you can come up with an idea of why people wandering through the desert occasionally see mirages that look like lakes in the distance. Go ahead, I'll give you a couple minutes to do this, and then we'll see what we can figure out about it. Alrighty, so this is obviously not the ideal situation with this. Along with a lot of things in physics, I like to get people together to discuss questions and try and figure out answers on your own. Obviously, with the pandemic and stuff, I can't have you gather together in groups that you'd want to pick and send you to different places in the room. A lot of times I would have you use the little whiteboards in the back to try and diagram what you might think. So we're just going to have to make do with what we can. But I'm interested, what kind of answers do you have for this? What could cause these images to pop up? You know, I suppose the first question would be, is it all hallucinatory? Or is it something that's actually physically happening there? What do you think about that? Yes?
Well, mine's probably wrong, but I just thought, because, like, the sand has, like, a natural kind of glare to it, I was like, maybe the sun, like, the light beams are bouncing off and making it reflect to make it look like kind of like...
Sure. Okay, so it would be something physical.
Yeah.
Okay, not just pretend. Yes?
I thought that they were just tripping because they're in the desert and, like, they want to see water. But then he said that, you know how when you're going down the street, right? And, like, you can see kind of, it looks like water on the street kind of.
Yeah.
Like
Right, yeah. So you're not sure. It could be one or the other.
Or both.
You could either be tripping, or it could be something physical. So I guess we might want to ask, is it something you could actually record, you know? If you're seeing this, would it actually show up if you took a video of it?
Like if you're well hydrated.
Yeah, if you're well hydrated. So let's just take a quick vote. How many people believe that this is something that's just going on in your minds? Maybe because of dehydration, maybe a hallucination is happening. How many people are leaning that way?
I say both. Like it's a combination.
You could say both. How many people... What's that? Yeah, more along the lines of hallucination?
No, like what she said is both.
Oh, both. Okay. So if it's both, would it show up on like a camera if you took a picture or a video?
No.
If it's both, would it show up on a camera or a video if you took a picture?
Maybe.
No.
I mean, if you want to see it.
So maybe only if you're tripping, right?
Yeah.
No, yeah, it could. It could. It could.
Right, right.
Depending on the angle, it definitely could.
Okay. So then how many people are leaning a lot more towards it being something physical that's actually happening here that we can talk about? Okay, good. So that's true. It is something physical that's going on. It's not just something that's happening inside your mind. So I heard one guess from Olivia, right? And she said that it might have something to do with the light rays coming off the sand, reflecting off the sand. Any other thoughts on what might cause something like this to happen? Yes?
Like the heat rises from the ground, and when it moves around, the light reflects off of it, and then in the distance you can see it moving.
Okay.
It's like water.
So it's kind of like heat waves, and it makes it look a little fuzzy and stuff. And I suppose if it's wavy like that, people could interpret that as like waves from a sea or something. Interesting. Any other ideas out there on how this might actually work? You guys are doing really good. Yes. Right. So it has something to do with heat and light. With no. Sure. So this isn't something that would happen like in Antarctica or something, or in the wintertime if it's cold. What's that? Oh, in Antarctica? Yeah, there's water, but there's no heat. So, well, there is heat, but it's really cold. So here's the thing. You guys are pretty much right on the money here. And it's about as far as you can get with this without actually understanding something about light rays that I'm going to teach you right now. I'm going to go ahead and I'm going to draw the solution for you. And I'll have you copy that picture down. And then we'll talk about exactly why light behaves so irrationally. After I spent an entire day telling you that light moves in a straight line all the time. He's a little worried because he is in the desert. The red hot desert. The sun is up here. And of course, the blue just kind of represents the sky. When you look in the distance along the horizon in the desert, because it's nice and flat, you're going to see the sky there. Same with what's going on up above you. In terms of what's going on with the light rays here, you guys are going to get a kick out of this. This is more or less what's happening in a mirage. I'll explain in a little while. The blue thing represents a light ray coming from the blue sky. I have it kind of curving. You could draw it straight starting from here if you want. So, light's doing some pretty funky stuff. The question is, why is light doing this? So there's two things you need to write down in words about this. Number one, light takes the fastest path to your eyes. Light will always take the fastest path to your eyes. Number 2, the hotter it is, the faster light will travel. The hotter it is, the faster light will travel. So if we combine those two things, you kind of see, and this is an exaggeration, it doesn't curve so profusely in the real world like this. And these distances would be much greater. You know, the distance from here to here would probably be like 3 football fields or something. So what's happening is, because light always has to take the fastest path to your eyes, and because it's warmer along the ground, and light travels faster in heat, what ends up happening is it actually takes this beam of light shorter to go like this along the ground and into your eyes, as opposed to just going a straight line from here into your eyes. Because the ground is so warm, and because light travels so much faster in warm temperatures, the light rays do this. And so when they come up into your eyes, here's where this really gets kind of interesting. Your brain, when light rays go in, automatically assumes that that light ray has been moving in a straight line forever. So your brain registers this light ray, and it assumes that it's been coming in this direction, from this direction, the entire time. So what do you suppose you see right here? What's that? You see the heat. You see, essentially, a light ray coming from the sky. The sky is blue. That's why you see the blueness on the ground in the desert. That's what causes the mirage. What you're seeing is actually light rays from the sky. And because these light rays are not all doing the exact same thing, you've got some light rays that might be coming up at a little bit of a different angle, or coming down at a little bit different of an angle. They interact with each other, and you get that waviness effect that Brooke, right? That Brooke was telling us about earlier. And that's what causes these mirages to occur. Number 1, light always takes the fastest path to your eyes. And number 2, the ground on the desert is a lot hotter than the air above it. And so it has to go along the ground because it's going to move faster over that area than anywhere else. Yeah? Yes. Yep, and I can actually Google it if you want. We can take a look at some of these pictures. But this is the sort of thing that you will see on the road too. Because the road oftentimes is warmer than the air above it, especially if you have a black road. Because, black asphalt absorbs all that heat, and it causes this effect to be more pronounced. Because the hotter the ground is, the more those light rays are going to be affected. Yes?
Wait, so is the light still going in a straight path? Or is it like...
No, it's bending a little bit. Now again, this is an accentuated version of what's going on. If I were to draw this in reality, I'd have to make the person much tinier. And, the light ray from the sky might be from this part of the horizon right there. So it's going down the ground a little bit, and then it would come up a little bit. So the angles are not this big in the real world. One thing you'll notice is when you're on the road and you see this, if there are trees on either side of the road, the sea that you see there, the mirage that you see there, would be green. Because a lot of times, you don't just have a clear view of the blue sky. If you're surrounded by green trees, light rays from those trees will do the same thing. They will take the fastest path to your eyes along the warm ground. And you'll see green right here. Oftentimes it's a reflection of whatever's surrounding you or right in front of you. So we can go ahead and let's take a look at some of these. I just put mirage into Google Images. You can see some of these effects here. And so notice, yeah, it looks kind of like a C, but if you look right here, you can see an exact, I'll make it bigger. You can see the reflection of the hill right there. So the light rays from the hill are going along the ground because it's warmer at the ground level, and that's the fastest path. They angle up a little bit into your eyes, so your brain assumes that those light rays came from the ground because of the angle they're entering your eyeballs. Pretty common one here. Same idea. Whatever is around you, whatever is above you, it's oftentimes just a reflection of that. I'm going to see if I can find a good one from the road. Yeah, there you go. And that's more a reflection of the sky. If you look on the right side of it, you can see some of the green from the bushes. So this isn't something that just happens over huge distances. It also can happen for close distances if the temperature difference is big enough. See if I can find one more good road one. Yeah, same thing here. You can see on the edges that it's green. So it's not just the sky, it's the trees that behave this way too. Bless you.
That's the first time I heard bless you all like since the corona started.
Oh, really?
Yes, I've never heard someone say bless you.
Huh. Well, you'll hear it in this class.
Yeah, I don't even say bless you anymore. I just be working.
So, questions on that craziness? You'll never look at those mirages again. Look at those mirages the same way again, will you?
Never.
I think of you.
What's that? You'll think of me? Awesome. Yes.
When does it start to go up, though?
When does what start to go up?
The light ray?
Different times. It depends on how warm the surface is.
I said when, not why. Or I said why, not when.
Oh, because the light rays, let's see. This light ray is going to end up going in tons of different directions. You've got a light ray from this location going there, and there, and there, and there, and there. And this one is going to take this individual path. But another one of these light rays headed at a different angle is going to take a different path and not get into your eyes. So they're going literally everywhere. So it's not just like one light ray that's doing this, because if you move up here, you'll see a different light ray from a location that's not quite the exact same, and you'll still see the exact same thing. Other questions? Yes.
Does it have to be a certain temperature for this to happen?
The hotter the better.
What
So-
temperature will the lights start at? Do you know? Like around?
It has more to do with temperature difference. If the road is, say, 80 degrees and the rest of the air above it is like 60 degrees, that would be a recipe to see something like this. Yeah. No? And this happens a lot when the sun's out, because when the sun's out, it's really baking that road, which makes the air just above the road a lot hotter and a lot more different than the air that we experience higher up. So, other questions? Cool. Let's take a look at worksheet numbers 1 and 2. We'll see what questions you guys have.
Oh, can I have another sheet?
Sure. Top tray in the back. What would you like to talk about from worksheet 1 and or 2? 5E. Unless there is fog in the air, it is not possible to see the beam of light going from the spotlight in the ceiling to the performer. How come? Okay. So, can you see this laser beam? Yeah, pretty clearly. I wonder if you can see it on the video. Yeah, a little bit. So the reason you can see this is because there's actually a lot of stuff in the air in this classroom. There's dust. There are other particles in the air from the vents. Maybe a little bit of asbestos. Hopefully not too much. But without that stuff in the air, you're not going to see this beam of light. This laser beam needs something to reflect off of in order for us to actually see it. Otherwise, we would just see it in the back of the classroom shining up the wall. Yeah, you can touch it. If anyone wants to high-five the laser beam, feel free. Just don't stand up and get it in your eyeball. Yes.
Bet.
Blind you?
I do be short.
Yeah, this is a pretty powerful laser. The red ones you usually see would not blind you, but if you...
Not just do it.
What's that?
I said I'm blind enough.
So yeah, if there's nothing in the air, you're not going to see this laser beam. That's why when you go to your heavy metal concerts, there's so much fog in the air because they have an awesome laser light show that goes along with it. Without that fog, there's nothing for those lasers to bounce off of, and you're not going to see them. So the same thing's true with this question right here. Unless there's fog in the air, it's not possible to see the beam of light. How come? Because that beam of light needs something to reflect off of for you to see it. That beam of light needs something for you to reflect, for it to reflect off of, for you to see it. It's one of the reasons if you're at a concert with a lot of people, it can sometimes feel humid. They like to increase the humidity in there because all that humidity helps those lasers and lights show up for you to see. Other questions?
Number 5 and the worksheet.
Number 5, worksheet 2.
Just like the soul part of that.
Sure. Okay, so number 5 on worksheet 2, we've got 2 light sources on the bottom, then we've got that object above it. So we got to just show where the shadow regions are. So what we would do with this is take our straight edge, and just remember what we have to do whenever we see an obstruction like this, and we have to find a shadow. And that's, you got to draw light rays that just barely graze by each edge of your obstruction. So in this case, I would draw one light ray like this, because it just barely goes by that edge, and another light ray going by the other edge. I would do the exact same thing for the other light source then. One light ray goes by this side. One light ray goes by the other side. So now we just have to figure out where the shadows are. Is there a shadow here? You betcha.
Yeah.
Not a single light ray is going to make it to this location. So this would be a full shadow region. Over here, all the light rays from this light source can freely make it over here. No issues there. But no light rays from this guy can make it. All those are being blocked from making it anywhere in here. So this would be partial shadow. And that's what that one would be. Same thing with the right side. Other questions? Going once. Going twice. Okay. Take your worksheets and actually, I suppose I should collect them so you don't exchange germs. I'll just grab them from you. I'll get those in the grade book. Thank you very much. Oh, right. That's okay. I'll get it in the grade book for you, and you can finish. Thank you. Thank you very much. And I'll get that for you now, and you can finish it up. There you go. And same thing. You can finish it when I hand it back out the day. Yep. Alrighty, so as of the end of school today, then the answer key for this worksheet will be available in the answer keys folder in Schoology. So feel free to check that out and see how the rest of your answers match up. Well, we got a couple minutes. You guys want some homework?
No.
Yeah, I don't really want to grade it either. I have this little book of questions that sometimes I use on days where we've got a little bit of extra time. There are 217 questions, and they're just like random weird questions. They're kind of cool. Would anybody like to volunteer to pick one and answer one? You want to? Alexa's got this. What number, Alexa, between 1 and 217? 72. Let's see what 72 is. Alright, this will be a good question for the entire class, too. Okay, we got 67. Yep. If you could have free unlimited service for 5 years from an extremely good cook, chauffeur, housekeeper, masseuse, or personal secretary, which of those would you choose? Cook, chauffeur, housekeeper, masseuse, or personal secretary. Someone who massages you.
Oh, I'm getting
How
that.
many people for the cook? How many people for the chauffeur? How many people for the housekeeper? Masseuse. Personal secretary. Okay.
Probably the smart choice.
I'd probably do a cook. Alrighty. You guys have a good weekend.
That's it? This one person?
That's it. We only had a couple seconds. You're going to freshman mixer, have fun.